Welcome to Lecture 5. Continue to talk about on using explicit cursors in PL/SQL. In this example, we use a parameterized explicit cursor to find the manager of a specific department. We declare a cursor CSI cursor that takes a department name as a parameter and returns the manager's full name and email. We also declare a record variable CEI man to store the fetched row and a variable SDEP for the department name, in this case, marketing. Next, we open the cursor with the department parameter and fetch the data into CCMan. We check if the cursor returned no rows using %NotFound, and then determine the manager's identity by examining the email. Finally, we close the cursor and check sizeopen to confirm that the cursor is closed. This example shows how parameterized cursors can make queries flexible and how cursor attributes help control program flow efficiently. In this example, we update the salaries of employees in Department 100 by 10%. After performing the update, we use the cursor attribute SQL%RowCount to find out how many rows were affected. We store this value in the variable nCount and then display it using DBMS output put line. This simple approach allows you to track the number of records updated in a DML operation efficiently. In this example, we delete a specific employee from the employees table. We declare a variable EFI employee ID with the employee ID to be removed, and another variable rows deleted to store the result. After executing the delete statement, we use CQL%RowCount to find out how many rows were deleted. Finally, we store this information in the rows deleted variable. Using SQL_RowCount helps us track the impact of DML operations like delete in PL/SQL. Using parameters for cursors makes them more flexible and reusable in PL/SQL programs. In this example, we declare a parameterized cursor cursGetOrder that takes an order number as input and returns the corresponding order date. We then open the cursor with the order number 100, fetch the result into a variable vDate, and close the cursor. The advantage is that the same cursor can be reused later for other order numbers such as 200, 210, 300, or 500, simply by opening it with a new parameter. This approach reduces code duplication and makes your PL/SQL programs more efficient and maintainable. In this example, we use a parameterized cursor to retrieve the hire date of a specific employee. We declare a cursor getDate that accepts an employee ID as a parameter and selects the corresponding hire date. We also declare a variable ddate to store the fetched value. Next, we open the cursor with the employee ID 100, fetch the hire date into ddate, and then close the cursor. Finally, we display the retrieved date using DBMS output put line. Using parameterized cursors like this makes it easy to reuse the same cursor for different employees without rewriting the query. In this example, we use a parameterized explicit cursor to find the manager of a specific department. We declare a cursor CCursor that takes the department name as a parameter and returns the manager's full name and email. We also declare a record variable CMan and set the department to marketing. Next, we open the cursor with this department, fetch the data into CMan, and check if the cursor returned any rows using _NotFound. We then determine the manager by checking the email. In this case, the output shows that the manager of marketing is Mhart. Finally, we close the cursor and confirm using _FunISOPen that it is properly closed. This example demonstrates how parameterized cursors and cursor attributes help retrieve and validate data efficiently. In PL/SQL, a select into statement can retrieve data into variables. By adding the optional bulk collect keyword, you can fetch multiple rows at once into an array. This is especially useful when dealing with large amounts of data. Fetching one record at a time in a loop creates a performance overhead for each row, which can significantly slow down execution. Using bulk collect into reduces the number of context switches between SQL and PL/SQL, allowing records to be retrieved in chunks or even all at once. This approach greatly improves performance and efficiency when processing large datasets in PL/SQL programs. In this example, we use bulk collect to retrieve multiple rows from the departments table into an array. We declare a variable dep AR of type vary to store department IDs, and then select department IDs 10, 20, 30, 40, and 50 using bulk collect into. Next, we loop through the array and update the location for each department to 1300. We also print each department ID using DBMS output put line. Finally, we commit the changes. The output shows all the department IDs that were updated. Using bulk collect allows us to fetch multiple rows at once, improving performance compared to fetching rows one by one in a loop. Using bulk collect in PLSQL is a very efficient way to retrieve query results. Instead of looping through each row one by one, bulk collect allows you to store all the results in one or more collections in a single operation. This keyword can be used with select into, fetch into, and returning into statements. When using bulk collect, all variables in the into clause must be collections. These collections can store scalar values or more complex structures, including object types. This approach greatly improves performance, especially when working with large data sets in PLSQL. In this example, we use bulk collect to retrieve multiple rows from the employees table into PLSQL collections. First, we declare a collection underpaid to store all employees earning less than 5,000. We use select bulk collect into to fetch the data and then print the total count. Next, we loop through the collection to display each employee's last name and salary. We also declare another collection sum names to fetch the first 10 employees' first and last names. Using a loop, we print each employee's full name. This example shows how bulk collect can efficiently handle multiple rows, making it easier to process and display large data sets in PLSQL. In PLSQL, you can use bulk collect with the returning into clause for insert, update, or delete statements to capture affected rows efficiently. In this example, we first create a temporary table emptemp based on the employees table. We declare two collections, enums to store employee IDs and names to store last names. Then we delete all employees in Department 30 and use returning. Bulk collect into to capture the IDs and last names of deleted employees. Finally, we display the number of rows deleted using SQL%row count and loop through the collections to print details of each removed employee. This method lets you process multiple affected rows in a single operation, greatly improving performance. In PLSQL, you can use bulk collect with the returning into clause for insert, update, or delete statements to efficiently capture multiple affected rows. In this example, we first create a temporary table called emptemp from the employees table. We declare two collections, enums to store employee IDs and names to store last names. Then we delete all employees in Department 30 and use returning. Bulk collect into to fetch the IDs and last names of the deleted employees. We display the total number of rows deleted using SQL%row count and then loop through the collections to print the details of each deleted employee. This approach lets you process multiple affected rows at once, improving performance and making your code more efficient. In PLSQL, you can combine bulk collect with the for all statement to process multiple DML operations efficiently. In this example, we first create a temporary table called emptemp from the employees table. We declare a collection deps containing department IDs 10, 20, and 30 and two collections EIDs and DIDs to store the employee IDs and department IDs of deleted rows. Using for all, we loop through each department and delete employees in that department. The returning bulk collect into clause captures the deleted employee and department IDs for each iteration. Finally, we display the total number of rows deleted and loop through the collections to print details of each deleted employee. This combination of for all and bulk collect significantly improves performance when performing multiple DML operations in PLSQL. A cursor variable is a variable that holds a reference to a cursor. Cursor variables allow you to pass query results between different PL/SQL programs and provide more flexibility than traditional cursors. Some key capabilities include associating the variable with different queries during program execution, passing the cursor variable as an argument to a procedure or function, assigning the value of one cursor variable to another. The basic syntax involves defining a ref cursor type. For example, you can declare a type with a specific return structure like sale cur type is ref cursor return sale% row type, or a generic cursor like cust cur type is ref cursor. This makes cursor variables a powerful tool for dynamic and reusable PL/SQL code. In this example, we use a ref cursor to retrieve department IDs dynamically and then process employees in each department. We first declare a cursor variable CESI_cursor of type cur type. Then we open it for a query that selects department IDs where the department name starts with A. Next, we loop through each department using the cursor and fetch the department ID into dpID. We exit the loop when no more rows are found using %NotFound. For each department, we select employees belonging to it and print their employee IDs using dbms output put line. Using a ref cursor allows this program to dynamically associate the cursor with different queries at runtime, making it more flexible and reusable. Thank you for listening. We appreciate your time and interest in this topic.